Okay, so I'm here with Dennis on the Panduit booth, and you have an exciting new solution, so please tell us a little bit more about it.
Yeah, so what we're showcasing here today is our high-density rack that supports direct-to-chip cooling as well as high-density power. In today's growing AI data center applications, it's critical to have a rack that can support heavy loads, in this case up to over 4,000 pounds dynamic rolling, because these racks are being configured off-site. So you need a heavy-duty rack. And in support of that heavy-duty rack, we are showcasing direct-to-chip cooling. And in this case, the ability to support those AI emerging applications. Direct-to-chip cooling is becoming very common and critical to the overall infrastructure being deployed. Solution that you're looking at here encompasses water manifolds, cooling distribution unit, referred to as CDU, and then of course all the plumbing that's going to connect the two together. In order to support these high density servers that are being deployed, you need PDUs that are also high power capable, as well as the ability to be connected so you can intelligently monitor those PDUs, monitor the outlets, turn an outlet on or off as needed to either reboot a server or do other types of maintenance within that particular rack. Also showcasing here, wouldn't typically be in the rack, but is the dashboard. So you can get your real-time information as to the loads being put upon the various PDUs at each rack. You could also use that dashboard for environmental monitoring, so I can understand what the back of the rack temperatures might be or front of rack temperatures. Now, with direct-to-chip cooling, the heat is pretty much all being captured through the cooling system. But other factors such as inlet supply air and call it ambient temperature of your data center, you still get a lot of information there. Security, so access control. These racks, given the importance of security in the data center, you could have electronic access with badged readers to only allow certain individuals into those racks. The racks, various heights, we're seeing taller racks be deployed in data centers, reaching up to 52 rack units in the white space.
I'm just wondering, in terms of Panduit, is this all of your technology? Are you partnering with people? How's the solution come together, if you like?
Yeah, so majority of it is Panduit solutions. We are partnering with people in the cooling industry to bring our direct-to-chip cooling solutions forward. With that is, cooling distribution units are being done in partnership with a strategic partner of ours. Outside of that, the manifolds have been kind of tested in our R&D lab, so we're able to thoroughly validate this design in our research labs that we have back in the United States. We're able to simulate the heat loads by generating real-time and temperatures, and then running cooling lines through it so we can measure the flow, making sure that everything is operating the way it should in call it a mock-up type of an environment.
And I'm just wondering, in terms of, obviously the world's gone sort of AI crazy.
Yeah.
Is that where most of your focus is at the moment, or is there still good business in what we might call traditional, data center environments? Just anything you can share.
Yeah, that's a really interesting topic. So the large language models, being driven by these AI data centers is going to transition into inferencing. And that's going to really make its way into the traditional on-prem data center. The on-prem data center is set to explode as AI workloads in the workplace start to increase and AI is leveraged more. So yes, there's the big buzz, the large hyperscale data centers and AI data centers being built. but modernizing the existing on-prem data centers and investment there is going to be paramount moving forward. So it's an area that Panduit is very focused on because they have a larger journey that I think they might have to go on. Their installed power, their installed connectivity, their level of ability to cool, all that infrastructure needs to be modernized in some way in order to support these higher density power, cooling, and connectivity requirements.
I'm just wondering as well, I mean, I do some work in the semiconductor space, and co-packaged optics is a big buzz area. I'm wondering, is that something that you're also sort of getting involved with? And if you are, where is it at the moment?
Yeah, I would say it's really starting to emerge. I think we're seeing it in some of the new NVIDIA solutions that are coming out where co-packaged optics, what it's doing is it's putting more connectivity at that server as well. And that connectivity is going to smaller form factors, connectors that we call very small form factor connectivity, connectors like an MMC connector or a SNMT connector. So onboard optics, I think, is emerging. We haven't necessarily seen it impact our structured cabling business, and that. What we've seen is just an uptick in the amount of fiber that's going to need to be deployed in order to connect with those devices.
And is there anything else keeping you busy, whether it's sort of market opportunities or any sort of technology trends that you're looking at closely?
I think for us, keeping pace with advancing fiber optic connectivity solutions. As I alluded to, we're seeing smaller form factor connectors, yet the fiber counts keep getting bigger and bigger. So requests for 2880, 3456, and bringing more fiber into the data center is really pushing in a lot of different ways. The fiber construction going from 250 micron to 200 micron fiber is really causing a lot of development that we have to do in order to adopt to that changes in the fiber cable constructions. So I would say lots of research being done in the area of fiber connectivity, advanced optics as we're going from 800 gig to 1.6 terabyte. That's happening, and it's happening very fast.